In Helvetica compressed, extra compressed, and ultra compressed, this rigid 18-unit system really boxed me in. It kind of determined the proportions of the design. Here are the typefaces, at least the lower cases. So do you look at these and say, poor Matthew, he had to submit to a problem, and by God it shows in the results? I hope not. If I were doing the same job today, instead of having 18 spacing units, I would have 1,000. Clearly, I could make more variants, but would these three members of the family be better? It's hard to say without actually doing it, but they would not be better in the proportion of 1,000 to 18, I can tell you that. And my instinct tells me that any improvement would be rather slight because they were designed as functions of the system, they were designed to fit. And as I said, type is very adaptable, it does hide its methods. All industrial designers work within constraints. This is not fine art. The question is, does a constraint force a compromise? By accepting a constraint, are you working to a lower standard? I don't believe so, and I've always been encouraged by something that Charles Eames said, that he was conscious of working within constraints, but not of making compromises. The distinction between a constraint and a compromise is obviously very subtle, but it's very central to my attitude to work. Remember this reading experience? The phone book, I'll hold the slide so you can enjoy the nostalgia. This is from the mid-70s, early trials of Bell Centennial typeface I designed for the US phone books. And it was my first experience of digital type, and quite a baptism. Designed for the phone books, as I said, to be printed at tiny size, on newsprint, on very high-speed rotary presses, with ink that was kerosene and lac. This is not a hospitable environment for the typographic design. So the challenge for me was design type that performed as well as possible in these very adverse production conditions. As I say, we were in the infancy of digital type. I had to draw every character by hand on quadrilateral graph paper. There were 4 weights of Bell Centennial. Pixel by pixel, then encode them raster line by raster line to keyboard. It took 2 years, but I learned a lot. These letters look as though they've been chewed by the dog or something or other, but the missing pixels at the intersections of strokes or in the crotches are the result of my studying the effects of ink spread on cheap paper and reacting, revising the font accordingly. These strange artifacts are designed to compensate for the undesirable effects of scale and production process. At the outset, AT&T had wanted to set the phone books in Helvetica. But as my friend Eric Spiekerman said in the Helvetica movie, if you've seen that, the letters in Helvetica were designed to be as similar to one another as possible. This is not the recipe for legibility at small size. It looks very elegant up on a slide. I had to disambiguate these forms of the figures as much as possible in Bell Centennial by sort of opening the shapes up, as you can see in the bottom part of that slide. So now we're on to the mid-80s, the early days of digital outline fonts, vector technology. There was an issue at that time with the size of the fonts, the amount of data that was required to define and store a font in computer memory. It limited the number of fonts you could get on your typesetting system at any one time. I did an analysis of the data and found that the typical serif face you see on the left needed nearly twice as much data as a sans serif in the middle, because of all the points required to define the elegantly curved serif brackets. The numbers at the bottom of the slide, by the way, they represent the amount of data needed to store each of the fonts. So the sans serif in the middle, sans the serifs, was much more economical, 81 to 151. Aha, I thought, the engineers have a problem. Designer to the rescue. I made a serif type, you can see it on the right, without curved serifs. I made them polygonal, out of straight line segments, chamfered brackets. And look, as economical in data as a sans serif. We call it charter on the right. So I went to the head of engineering with my numbers and I said proudly, I have solved your problem. Oh, he said, what problem? And I said, well, you know, the problem of huge data serif fonts and so on. Oh, he said, we solved that problem last week. We wrote a compaction routine that reduces the size of all fonts by an order of magnitude. You can have as many fonts on your system as you like. Well, thank you for letting me know. I said, foiled again. I was left with a design solution for a non-existent technical problem. But here is where the story sort of gets interesting to me. I didn't just throw my design away in a fit of pique. I persevered. What had started as a technical exercise became an aesthetic exercise, really. In other words, I'd come to like this typeface. Forget its origins, screw that. I like the design for its own sake. The simplified forms of Charter give it a sort of plain-spoken quality and unfussy spareness that sort of pleased me. You know, at times of technical innovation, designers want to be influenced by what's in the air. We want to respond. We want to be pushed into exploring something new. So Charter is a sort of parable for me, really. In the end, there was no hard and fast causal link between the technology and the design of Charter. I'd really misunderstood the technology. The technology did suggest something to me, but it did not force my hand. And I think this happens very often. You know, engineers are very smart. And despite occasional frustrations because I'm less smart, I've always enjoyed working with them and learning from them. Apropos, in the mid-90s, I started talking to Microsoft about screen fonts. Up to that point, all the fonts on the screen had been adapted from previously existing printing fonts, of course. But Microsoft foresaw correctly the movement of the stampede towards electronic communication, to reading and writing on screen with the printed output as being sort of secondary in importance. So the priorities were just tipping at that point. They wanted a small core set of fonts that were not adapted, but designed for the screen to face up to the problems of screen, which were their coarse resolution displays. I said to Microsoft, a typeface designed for a particular technology is a self-obsoleting typeface. I've designed too many faces in the past that were intended to mitigate technical problems. Thanks to the engineers, the technical problems went away, so did my typeface. It was only a stopgap. Microsoft came back to say that affordable computer monitors with better resolutions were at least a decade away. So I thought, well, you know, a decade, that's not bad, that's more than a stopgap. So I was persuaded, I was convinced, and we went to work on what became Verdana and Georgia. For the first time working not on paper, but directly onto the screen from the pixel up. At that time, screens were binary. Pixel was either on or it was off. Here you see the outline of a letter, the cap H, which is the thin black line, the contour, which is how it is stored in memory, superimposed on the bitmap, which is the gray area, which is how it's displayed on the screen. The bitmap is rasterized from the outline. You know, here in a cap A, which is all straight lines, the two are in almost perfect sync on the Cartesian grid. Not so with an O. This looks more like bricklaying than typesetting. But believe me, this is a good bitmap O, for the simple reason that it's symmetrical in both X and Y axes. In a binary bitmap, you actually can't ask for more than that. You know, I would sometimes make, I don't know, 3 or 4 different versions of a difficult letter like a lowercase a, and then stand back to choose which was the best. Well, there was no best. So the designer's judgment comes in trying to decide which is the least bad. Is that a compromise? Not to me, if you are working at the highest standard the technology will allow, although that standard may be well short of the ideal. You may be able to see on this slide 2 different bitmap fonts there. The A in the upper one, I think, is better than the A in the lower one, but it still ain't great.